One of the challenges associated with studying interhemispheric asymmetries arises from the fact that no asymmetry stands in isolation. Take, for example, the case of the Earth's magnetic dipole, which is offset and tilted. This asymmetry can drive asymmetries in, for example, auroral precipitation, which can drive asymmetries in ionospheric electrodynamics, which can drive asymmetries in thermospheric Joule heating, so on and so forth. This means that it is impossible to study any asymmetry in isolation. Instead, you must understand the cause and effect context of that asymmetry throughout the magnetosphere-ionosphere-thermosphere system. The situation is more difficult if you want to use numerical models to study a certain asymmetry. It's often challenging to know if the model not only captures the asymmetry itself, but also the causes and effects required to accurately simulate the space environment. To deal with this challenge at CUSIA, we're developing a new tool called the CAM, the Capabilities Assessment Matrix. This is an interactive website consisting of a series of articles on different interhemispheric asymmetries. Clicking on the title brings up a detailed article about the asymmetry, its causes and effects, as well as a summary about the capability of different models in the community in terms of reproducing that asymmetry. We have specific information about certain models most relevant to each asymmetry, so you can quickly know if the tools you're using are appropriate. Additionally, each article has a series of keywords, such that if you click on one of those keywords, it will bring up all the articles that share that keyword, and you can see the interconnection between different interhemispheric asymmetries. Naturally, creating a tool like this requires a lot of contributions and deep expertise. That's why today we're inviting you to contribute an article to the CAM to help make this tool as useful as possible across heliophysics. To make this process as easy as possible, we've developed an online form to ask you all the information required to make a complete article. Today I want to walk through the process of filling out this form so that you can see what it takes to build a CAM article. To start, pick an asymmetric topic that is currently missing from the CAM. In this example, we're going to do asymmetric ionospheric outflow, a topic very near and dear to my heart. Next, we'll start to brainstorm about the causes and effects of that asymmetry. We'll think about the important papers in the literature that we want to reference, and maybe grab a figure or two. To help you organize your thoughts offline, we have linked here a Word document that has all of the fields and all the questions so you can build your article without staring at the web page for hours on end. As you can see, I've gone ahead and filled that out for the case of asymmetric ionospheric outflow. Returning to the form, we're going to go ahead and enter our email. We're going to type in the name of our interhemispheric asymmetry. In this case, it is asymmetric ionospheric outflow. And we're going to continue to this first question concerning, is this asymmetry intrinsic or dependent? An intrinsic asymmetry is a feature independent of the dynamics of the magnetosphere-ionosphere-thermosphere system. Take, for example, the Earth's magnetic dipole, or the tilt, the direction of the interplanetary magnetic field. Those do not depend on the MIT system. A dependent asymmetry is something that is a downstream effect from one of the intrinsic asymmetries. And so that's what we're going to choose here for asymmetric ionospheric outflow. Next, we're asked to describe the asymmetry. So I'm going to go ahead and copy and paste what I wrote in the Word document here, and I'm just very briefly describing it. The rate of ionospheric outflow of light and heavy ions can be highly asymmetric between hemispheres, and I mentioned that this happens both on large and local scales across conjugate points. Next, we want to write about the causes of this asymmetry. So again, I'm going to copy and paste from my Word document, and I'm going to cover the most important things in this article. I'm going to start with the fact that asymmetric outflow is largely driven by differences in sunlight arising from dipole tilt and season and diurnal effects. I also mentioned that because outflow is driven by a variety of factors, each of which can be asymmetric themselves, there are a lot of drivers of asymmetry for ionospheric outflow that need to be considered. And I have a couple of review articles referenced here. Next, I describe an example from literature that I thought really helped illustrate the situation well. So moving on, we then have the effects of asymmetry. And again, I'm going to copy and paste what I wrote. And here I emphasize the fact that the effects of this asymmetry are really not well understood in the field today. And the CAM is really a great place to talk about unknowns because this is a growing field of study. I mentioned that there are implications for the ionospheric supply of magnetospheric plasma, the development of the ring current, but mentioned that a lot of this has yet to be explored. Next, I wrote very briefly about how we are working on this topic at CUSIA and have found that this has implications for changing the tilt of the magnetotail and affecting tail conditions. And so that's something certainly relevant here. Next, if you have any figures, you want to go ahead and upload them now. It's just a matter of dragging and dropping to upload them. Next, we want to add captions to our figures, which is just a matter of giving them figure numbers in the same order that they appear in the article, mentioning if they belong in the causes or the effects section. Here, this is going in the causes section. And then I'm going to very quickly copy and paste there we go, my caption right there, so that is included. Next, we want to discuss modeling capability in more general terms. So I'm going to paste the paragraph I wrote. I talked about how global magnetohydrodynamic models can include this through setting inner boundary conditions in different ways. I give a couple of specific examples with relevant citations that I think will really help illustrate the point. And then I move on to the major physics-based outflow models that have shown that they can capture both the northern and southern hemisphere independently. The polar wind outflow model, GPW, and IPWM. Once I have that written up, I'm going to go ahead and hit next. In this next section, we ask you to briefly describe specific models most relevant to this asymmetry in terms of if and how they capture the source of asymmetry. And this really should be a very short sentence for each. Now, in the form, we start with well-known global MHD codes, but we have plenty of space for other models well. And if global MHD is not very relevant to the asymmetry at hand, feel free to just write nothing there and we won't include it. For the MHD models, I know that both LFM and BATS R Us have this capability. So I've just written here that yes, via coupling to other models or via explicit inner boundary conditions. Now with OpenGGCM and GUMX, I actually don't know if they can handle this. I assume they can, but I haven't seen it in literature, and for me that's just a point of ignorance. So I'm going to explicitly write unknown, and that's okay. Next, there are a whole bunch of other models that are important to include here, such as the polar wind outflow model, which I'm going to copy and paste my text here. But both hemispheres must be turned on explicitly. And the same thing goes for GPW and IPWM. So I'm just going to paste that in, and that very quick summary will be very useful for people browsing very quickly. So moving on to the final page, we're going to turn to our references. And to keep this as easy as possible, we just ask you to provide a DOI associated with each first author year combination, so we can make those links in the article very quickly, as well as fetch the bibliographic information from the web as quickly as possible. So that's done. Finally, we turn to article keywords. And here, we're not asking you for just a list of terms associated with different causes of effects, but to go to the other CAM articles and draw inspiration there. What keywords are being used that are also relevant here? For example, certainly dipole tilt, diurnal effects. I have a whole list actually that I should be copying and pasting that I know are being used by other articles. There we go. We'll just actually have it. There we go. Diurnal differences, asymmetric precipitation. And the reason we first turn to keywords being used by other articles is because this is how we make the connection to the other CAM entries and build that web of knowledge. Now, if a term isn't used by other articles, that's fine. Absolutely be the first to add it right here. To make the process a little easier, we have a link right here to a list of the keywords that are already in use to help you make that decision as fast as possible. So I'm going to go ahead and add a list of my effects keywords. And what you'll see as you're browsing is that the different asymmetric effects are almost certainly going to be causes on a different article because of the cascading nature of interhemispheric asymmetries. So at this point I hit submit, and at Cusia we're going to review your article and try to get it online as soon as possible. But this is not where the process ends. For each of these articles there is a comment section open only to people who sign up for the Cusia website. We ask people to respectfully comment on the different CAM entries. Perhaps you see that the author was missing a key piece of knowledge. For me, it was the fact that I honestly don't know if OpenGGCM and GUMX can include asymmetric interhemispheric outflow. So you might comment with a reference or a link to a talk showing that that capability does exist. Or perhaps there's a different figure or a different paper you felt the author should be including, or there's a deeper explanation or more effects that should be added. And we can address that in the comment section. At Cusia, we're going to be reviewing that comment section periodically to keep the CAM as up to date and complete as possible. And in that way, we'll try to make a living, useful tool to help people who are studying interhemispheric asymmetries. So with that, thank you very much for your time, and I hope to see your contributions soon.